Let's do it. Yes, dilute hydrochloric acid. Formula. Chemically, it's hydrogen chloride, okay? H plus Cl minus. So this is the acid. Now, we just now saw on page 47 textbook, zinc is above here. So it will easily displace this and hydrogen gas will come out. Only H, but then hydrogen cannot be H, so gas, this one. So write down hydrogen. Hydrogen means hydrogen gas, okay? Now, plus, this plus this test means with Cl chloride ion means zinc chloride. There is no other formula that you can come out. Zinc and chloride you write below because we always want to keep space this side on the right side. So formula by starter, remember? Yes, Zn2 plus and chloride ion. Yes, Cl1 minus. So here 1, here 2. Can't cancel, so this 2 will go at the back of Zn. So zinc chloride, ZnCl2. Next thing we need to check, very important equation is, it must be balanced. Balanced means number of atoms on the left and right should be equal. Now how many Zn is here? Yes, 1. On the right side of the arrow, 1. Then it's already balanced so far. How many H here? At the back you see, no number means 1. Here, 2. Now we cannot balance from the middle, okay, or the back also. If you want to make 2 this side also, you must put it right in front. And that number 2 must be bigger than the back side 2. Because this is called the subscript and this is the main, means capital. Main means capital. So 2H and H to balance now. That's called balancing of equation. So we must make sure it's equal both sides, 2H, 2H. Okay. Now how many Cl? The one number here now belong to everyone after that, okay? 2Cl. So here also Cl2. Now it's balanced, nah? Zn1, Zn1, H2H, H2, 2Cl, Cl2. So this is balanced chemical equation. And we'll read one atom of zinc reacts with 2 molecules. Why 1 molecule? Because there are more than one atom, hydrogen atom, chlorine atom. Why did I say atom? Because there's only one type, zinc atom. So one atom of zinc reacts with 2 molecules of hydrochloric acid to give you 1 molecule, because there are more than one atom. See, H2. Duta, more than one atom is called molecule. Okay. 1 molecule of hydrogen gas or hydrogen and 1 molecule of zinc chloride. So this is the salt. Again, we see that zinc react with another type of acid also, different acid also. Hydrogen is common produced. So every time a metal reacts with acid, hydrogen will be produced. We can try with one more. Here, zinc. Okay, take zinc, same metal, it's a metal. Now, a little bit below the plus, which is on the same line, write acetic acid. Acetic acid. Why? Because this is a very common acid. Formula is CH3 COOH. Okay, star always worksheet 1W plus, remember. Now the replaceable hydrogen is not this, okay, it is at the back, it's a little bit different. And this will go and replace this because zinc is above hydrogen and hydrogen gas will evolve, will come out. Now in your tuition copy, I wrote H2 at the back, and now I'm writing front. Doesn't make any difference, okay? H2 plus ZnCl2 or ZnCl2 you write first, H2 second, no harm. It need not be in the same place. Should be on the same side, yes, but order is up to you. Then if this zinc take this place, what will you get? Yes, zinc acetate. Now this, when we write formula, okay, we usually write positive Zn2 plus first and negative SO4 minus 2 minus back. But exceptions are there, and this is one exception. CH3COO minus acetate ion is negative. We write that first one as it involves acetate ion, minus 1. Zn2 plus is going back. This is the only exception. Now this is 1, this is 2, means 2 will go at the back of this after bracket now, because there are so many atoms here, and 1 go there. So zinc acetate is CH3COO 2 bracket 2 Zn. So what is this? Zinc acetate. It's called zinc acetate. Now balance it, Zn, CH3COO 2. Here only 1, so we have to put here 2. 2C, 2C. Now 2 3s are 6 H, 2 3s are 6 H, plus 2 here. So let us count. 2 3s are 6, 2 1s are 2H. So here 6 and here 2H, because 2 belong to all of them now. 8. So here how many? 2 3s are 6 plus here 2H, equal. Both sides are equal. 8H, 8H. Now let's try the O. How many 2 inside? Count this one inside first. 1 2 O, so 2 2s are 4. Here how many? 2 2 2s are 4, equal already. H is done. Zn1 Zn1, 2C 2C, 8H here also, 2 3s are 6 plus 2 2 here, 8H. 2 2s are 4O here, 2O plus into 2 now, 2 into 2 4O here also, 2 2s are 4O, so it's balanced. So this is how a metal react with any acid will always give you hydrogen and the corresponding salt. These are called salts. So we can write the general answer in the end as, you say any metal, most metals in for that metal, any metal that is above hydrogen. Okay, that means you have to be careful to notice page 47 of your textbook. Here, all these metals that are above hydrogen, lead, iron, zinc, aluminium, magnesium, calcium, sodium, and potassium, they can react with acids. But the ones below won't react because they are below hydrogen. So cannot replace the hydrogen in the acids. Okay. So all metals above hydrogen will react with any acid to give you hydrogen gas and the corresponding salt. So you write here, metal above hydrogen plus any acid for that matter give you salt, its corresponding salt, and the hydrogen gas or hydrogen gas. So that's what we need. You can pause the video and read through once if you want. Okay, otherwise we'll go to the next part. Okay, next part. So that is the reaction of how acids react with metals. But the same question also says, how does it react with base? So for bases, let us take this for bases. For bases, let's take an example. Very common base is sodium hydroxide. This famous base is sodium hydroxide. Sodium hydroxide, write the formula above by remembering starter. Yes, Na plus and OH minus, so NaOH sodium hydroxide. React with metal. You took the metal here, zinc here also. So you can write Zn first or NaOH, up to you, okay? So zinc is the metal. What will happen? What you'll get is, interestingly, you will also get hydrogen gas again. On your tuition note, I've written hydrogen back, okay? But you're right, no harm. What is the formula of hydrogen? Worksheet 1 double plus. Hydrogen is H2, no, hydrogen means the hydrogen gas. Plus sodium, this one though you have to memorize, the name, not the formula, sodium plus a little bit below, right, sodium zincate. Now you write the formula, you can remember the starter. Yes, Na1 plus zincate, remember negative radical. That's right, ZnO2, 2 minus. So here 2 and the valency here is 1. 1 need not be shifted, 2 will go at the back of Na without bracket because Na is a single atom, simple ion. So Na2 ZnO2. Okay. So here we see here that some bases also react with metals and give the same result like metals, or like with acids. Some bases, metals react with some bases to give you, some metals react with bases, sorry, to give you hydrogen and the corresponding salt. But you must know this, in the case of bases, most of the bases do not react with metals, okay? But in the case of acids, all the metals above hydrogen react, so they react more easily with acids, metals, okay? So now you can read question number 14 detail and pause the video, go through the video again if you need to, but I think that it should be fine. But before that, let us, I'm forgetting, we have to balance Na1 here 2 though. So to make it equal, there's no Na here, so I have to put here 2. Now 2Na equal. How many O? 2O. 2 ones are na. Here nothing in the back means 1. 2 ones are 2O. No O here, so only 2 on the left side of arrow, 2O. Right side, no O, so here 2, balanced. How many H on the left side? 2 ones are 2H. Because there's no H here, so only 2H. Right side, H2. Because there's no, so it's balanced, no H here. Zn1 here, also at the back of, this 2 doesn't belong here. If the 2 is here, it will belong to Zn, but at the back of Na means belongs exclusively to Na only, okay? So Zn1 here also 1. So this equation is balanced. So 2 molecules of sodium hydroxide react with 1 atom of zinc to give you 1 molecule of hydrogen and 1 molecule of sodium zincate. So that's the equation. Go through the equations carefully because you will have to write them and balance them yourself. Okay, pause the video and seek properly if you need to. Now go to the next question. Just now we see how acids and bases react with metals. They react with metals to give hydrogen and a salt, right? Next question is this one. Question number 15. How do metal carbonates and metal hydrogen carbonates or metal bicarbonates react with acids? Okay, how do metal carbonates and metal hydrogen carbonates react with acids? So for this, to make it easy for you, let us do the equation first. So here, this is how they react with metal carbonate. Means many are there, but the most common one, easily remember one, we take question, write down question number 15. Now just below this you write sodium is a metal. Okay, sodium carbonate, so there's a metal carbonate. Now write the formula, you know, not the starter above it. Yes, Na1 plus CO3 2 minus, so 2 will shift here, 1 will not. So Na2CO3 is the sodium carbonate. This is the metal carbonate. So the question is, how will a metal carbonate react with acids, right? So you combine with a common acid, sulfuric or hydrochloric. Your textbook is using hydrochloric, so I'll use that one. Plus should be on the same line with this, a little bit below the plus. You write hydrochloric. When I say hydrochloric, we usually use the dilute. Okay, hydrochloric acid, the chemical name is hydrogen chloride dissolved in water. So H1 plus chloride starter. No, so this is the one. And you put AQ at the back, meaning it's the acid. If you forget also, it's fine, you've written here. Now you put a arrow. How will a metal carbonate react with an acid like HCl? That's the question. Now what happens is that this will combine. Na and Cl means, you know from starter, very easy to figure out, sodium chloride is the one that will come out. No? So write the formula, sodium chloride, write a little bit below arrow and write the formula near the arrow. Na1 plus Cl1 minus. Plus, interestingly, you just remember this, every time a metal carbonate reacts with acid, it gives the salt. Sodium chloride is a salt, okay? Water it will give surely, and then carbon dioxide, a little bit below the plus, okay? I read the formula, remember, starter or worksheet 1 double plus, carbon dioxide formula, remember? Yes, CO2, which is the gas, okay? Now sometimes textbook look at this, gas means the big G, liquid means L, water is liquid, and this is solid. This is actually dissolved in water, so AQ like that. Now you put is also good, even if you don't put it's okay. Now the next thing we do is balance. So every time a metal carbonate react with acid, we get salt, water, carbon dioxide. Any metal carbonate you take and react with acid, you will always get the corresponding salt, and the common always coming out is water and carbon dioxide. Let us balance. Na2 means here 2, no Na, so here put 2. Then 1C, here's another C, but this is not same, okay? This C is carbon and this Cl is chlorine atom, so we cannot count them together. This is carbon 1, C means carbon 1. How many carbon here? This is not carbon, C is chlorine, so 1, balance so far. O how much? 3, no O here. How many O here? 2, plus 1 here, because these 2 belong at the back, means belong to H only. Now at the back of O nothing means 1, 2 plus 1, 3, so 3 O3 balance, no O here now. H how much? Yes, 1 here, 2, no H, so 2 on the right side, so this should also be 2. We cannot balance at the back, between or at the back, so in the front. 2H, H2. Finally, Cl you check. 2Cl, here also 2Cl. Now it's balanced. Check once more. Na2, 2Na. C1, C1. O3, 1 plus 2, 3. 2H, H2. 2Cl, 2Cl. So this is balanced now. So remember, when a metal carbonate react with acid, we get salt, water, carbon dioxide. Then how about the metal bicarbonate? Example is, most common is the sodium. Many are there, okay? Sodium bicarbonate. How does an acid react with a metal bicarbonate or metal hydrogen carbonate? Because bicarbonate ion is also called hydrogen carbonate ion. So some textbook use like that, some will be using. You don't need to write both in exam. Sodium hydrogen carbonate, because this part here, see, hydrogen carbonate and bicarbonate are same. So sodium hydrogen carbonate, write the formula which started Na1 plus bicarbonate ion HCO3 1 minus 1 1. React with acid, hydrochloric acid. So write down hydrochloric. Slow down, pause the video if it's too fast. HClAq, that is the hydrochloric acid. Then you will get again the same result, sodium chloride. Interestingly, you get sodium chloride, so write that one. Then you will get the water for sure, H2O, and then you'll get a carbon dioxide. So the result is the same. Metal carbonate or metal bicarbonate react with acid to give the same result, salt, water, and carbon dioxide. So you balance it, Na1, Na1, H2, here also 2, C1, C1, O3, here 2 plus 1, 3, okay, here H1, 2, here 2, so it's balanced already. These some skeletal equations are there, they already come out balanced, we don't need to balance, and this is one of them. So remember this. Now here, go back to question. Let's see. So in the question here, you put the sodium carbonate before you put the cork, as I said. The cover the nala solid sodium carbonate halibi. So it is sodium bicarbonate, metal carbonate. It is test tube B, test tube A, metal carbonate halibi. Na you put the cork with 2 holes, and through one hole, that is the funnel, the glass, and the other one, the delivery tube to a lime water. Okay, this calcium hydroxide solution is called lime water. Then why we do that, we'll explain. Then here also same thing, you put it. Then slowly finally pour out the acid, so it will come in contact with the metal carbonate, and here it will come in contact with the metal bicarbonate. So we know that when acid react with the metal carbonate or bicarbonate, carbon dioxide gas will be produced. Just now we did salt, water, and carbon dioxide. So carbon dioxide gas will come out of this, and when it turns to the lime water, which is called calcium hydroxide solution. Calcium hydroxide solution originally is colorless, okay, but when carbon dioxide passes through this, it turns white, milky, because that confirms that carbon dioxide is coming out. Same thing happens here, okay. So the rest you can read through, okay. Take 0.5 gram each of sodium carbonate, sodium hydrogen carbonate in 2 separate test tubes marked A and B like we did just now. Set up the apparatus as I told you just now. Pour gradually diluted HCl into the TEST-2 funnel, so the lower tip of the TEST-2 funnel are dipped in the liquid. You know the reason, right? So that the gas won't escape out through the TEST-2 funnel. Just one question back we did it. This is to prevent the escape of evolved gases through the TEST-2 funnel, so that they are forced to go through the delivery tube. By now we see gas bubbles evolved from both test tubes. Now step 4, pass these evolved gases through the solution of calcium hydroxide, means lime water. We see that the evolved gases turns slack lime solution. It is also called slack lime solution, okay. Milky. Lime water is also called slack lime solution. Milky means white color because of the white produced, because of the white precipitate produced. This confirms that the gas evolved is carbon dioxide. So this is just to test that yes, carbon dioxide is coming out. To explain that, let me carbon dioxide turning milky, that part. So here, see, this is not part of the answer necessarily, but just to explain here. Chuna janena lime, the calcium oxide, in English we call it as calcium oxide. The real name is called lime in English, or quick lime. Nagamis we call it as chuna pande dalena. So you mix with water, Ca2 plus, oxide is O2 to cancel, and dissolve in water. So whenever you dissolve chuna in water, it's very simple. You'll get a clear solution on the right side, which is called slacked lime solution, slug lime solution, which is simply called lime water. Okay. Now the real name is calcium hydroxide. You can write it down. Calcium hydroxide. You can write it down. So make the formula with this chemical name, calcium. You cannot get the formula from here. Calcium hydroxide, Ca2 plus calcium ion, hydroxide, OH1 minus. So 1 go here, 2 going time, compound ions with bracket O and H, 2 atoms. So this is liquid, okay, and this calcium hydroxide is called slug lime solution. Now it is aqueous, means dissolve solution, dissolve in water. So this slug lime, you take this one, see, CaOH, 2 AQ means the solution, liquid. AQ means dissolve in water. Then whatever gas, carbon dioxide, coming out from the test tube here, after reacting with the metal carbonate, bicarbonate, the gas coming out will react with this calcium hydroxide, this one. So you write your carbon dioxide. Why it's turning milky is because they will react and produce calcium carbonate. Calcium carbonate formula from a little bit below the arrow, you write calcium carbonate. Yes, Ca2 plus CO3 2 minus. So 2 valency cancels, so CaCO3. This is milky white. That's why the solution is turning, the one which colorless solution is turning milky now, because carbon dioxide is reacting with it to produce calcium carbonate, confirming that the gas coming out is carbon dioxide, right? And the byproduct we always get is water. You can balance the equation if you want. Ca1 O2, because bracket is there, see, 2 plus 2 4, 3 plus 1 4, H2 C1. This is not CO, this is Ca, calcium. This is carbon, this is calcium. Ca is calcium, C is carbon. So Ca1, so it's balanced now. Okay, so I hope you got it. Okay, one more question is there, and that'll conclude the TEST-2A portion. Okay, so that is question number 16. So question number 16, let us see. Why do lime water, means like lime solution is called lime water, turn milky when carbon dioxide is passed through it? Just now we did it, see, same one you apply. So lime water, so you write here a little bit below, lime water, and write its chemical formula. Just now we know now, calcium hydroxide is the chemical name, calcium hydroxide. Write the formula Ca, this is called the lime water, OH bracket 2. When you pass carbon dioxide through this colorless lime water, this is colorless, why does it become milky? The question is that. Just now we discussed. Because they react and produce calcium carbonate, which is a milky white or simply white precipitate, PPT, means solid. Calcium carbonate, remember starter, Ca2 plus CO3 2 minus O2 and 2 cancelled. Then water is formed, Ca1 O3 O4, sorry, 3 plus 1 4, H2 bracket is there, so 2 1s are 2, C1 O4 balance. Just now we explained, double explain. So because of the formation of this white calcium carbonate, the colorless lime water turned milky. Okay, you can read the question. So that concludes TEST-2A portion. After you going through this, you take the test the next day, okay, following the instructions.